So this step 1 was keeping only 24 volts active. Let's now go to step 2. So let's now go through step number 2, in which we will keep the second source active. So let's say keeping 2 amperes active. So this is the 2 ampere source which I'm going to keep active. In that case, I'll have to replace the 2 voltage source. The very first source that I replace is this 24 volts. We will replace it with short circuit. So this is what we get. And we will also replace this 36 volts with a short circuit. Now we have to find out the value of Ix. Let me call this as Ix double dash, because that's the second value of Ix, and this time it is due to 2 ampere current source. Once again, one can go for mesh, nodal analysis, etc. If you now carefully observe, it is not very much required to directly apply mesh or nodal analysis like last step. We can first simplify the circuit a little bit. You can see this 20 ohm and this 20 ohm are in parallel because they are connected across the same 2 ends. So this 20 ohm and this 20 ohm, you can see both are in parallel. So let us club them. We have already done this in the previous step. 20 parallel 20 will result in 10 ohm resistance, and I can draw the equivalent circuit which will look something like this. So this particular branch remains. I'll start from here. 5 ohm resistance remains. Now what I'll do is I'll remove this 20 ohm resistance, and in place of this 20 ohm resistance I'll replace it with 10 ohm resistance. In that case, I'll be left out with this current source in the middle branch. So I'll just show the current source in the middle branch. This is the resistance, which is 10 ohm. That is the equivalent resistance for two 20 ohm resistances in parallel. This is my 5 ohm resistance which is originally present, and this is the current that I'm right now trying to figure out, Ix double dash. This is 2 amperes. You can see this is nothing but 2 resistors, 5 ohm and 10 ohm in parallel. Because they are in parallel, they are connected across the same 2 ends, and there's a current source of 2 ampere in between. So whenever that is the case, we can apply current division rule, something that we have already discussed before. So 2 amperes is the source current. A part of 2 ampere will flow through 10 ohm resistance, and a part of 2 ampere will flow through 5 ohm resistance. Let me call this currents as I1 and I2. So in that case, I can write down using current division rule, using CDR, current division rule. I can write down the value for I1. I1, because it's a current flowing through 5 ohm resistance, according to CDR, I1 will be the opposite resistance, which is 10 divided by 10 plus the resistance itself 5 multiplied by the source current, which is 2. So this will give me 10 upon 15 into 2, and therefore I1 is equal to 10 by 15 will be nothing but 2 by 3 into 2 will be 4 by 3. So that will be 1.33 amperes. But it is not I1 that what we were looking for. We were actually looking for Ix double dash. So as you can see, I1 and Ix both are flowing in the same branch, and because they are flowing in the same branch, their magnitudes will be exactly same. They are flowing in the same branch, but they are flowing in the opposite directions. I1 is flowing towards left and Ix double dash is flowing towards right. So because of this, because they are flowing in opposite directions, their values will only differ in negative sign. So if IF is 1.33 amperes, then we can easily write that Ix double dash will be nothing but minus of I1, and because I1 is positive, we will have to attach minus sign with 1.33, and hence my Ix double dash will be a negative current. So in this particular case, we get Ix double dash as minus 1.33 amperes. This plus or minus sign does not matter. We have to stick to the direction which they have mentioned in the question. So that's step number 2, in which we find current with keeping 2 ampere source active.